Today we are looking at the gradient-intercept form of a linear equation. So linear equations can be written in the form y equals mx plus c. So the point of writing a linear equation in this form is because it clearly states both the gradient and the y-intercept of the equation. So we know the gradient is represented as m, or it's the coefficient of x when it's in this form, and c is used to represent the y-intercept. Now, in some questions, you might read the gradient intercept form as y equals mx plus b. That's just a convention that's been changed over time. So we used to write it as b, we now write the y-intercept as c. So if the y-intercept is 0, then the equation of the line is simply y equals mx, where m is obviously the gradient. But that means that the line passes through the origin. And if we're going to sketch a graph using the gradient intercept method, so our first point, because obviously we only need 2 points to be able to sketch a graph, so our first point will be the y-intercept, and then we can just use the gradient to find a second point. So remember, the gradient is rise over run. So say, for example, your gradient is 3/2. That means for every 3 vertical units, the line will go across 2 horizontal units. So we'll just have a look at some examples now. Now, these examples are going to range from really super duper easy to a little bit harder, where you actually need to use your algebra skills to be able to rearrange an equation. Okay, so if an equation's already in gradient intercept form, we might be asked to state the gradient and the y-intercept of a linear relationship. So straight up, we've got y is equal to 2x plus 1. So straight away, you can see the coefficient of x is 2, so that's obviously our gradient. And we've got a 1 on the end, that's in place of our c, so the y-intercept is simply 1. So now we'll step it up a little bit, where we need to rearrange an equation that's not already in gradient intercept form. So if we have the equation 4x plus 2y equals 10, we need to put it into the form y equals mx plus c. So we want y on its own. So the first thing we need to do is get rid of that 4x that's on the left-hand side, and we want to move it over to the right-hand side. So because the 4x is positive, we can subtract that to move it over to the other side. So if we do that, we'll have 2y is equal to 10 minus 4x, or the other way we can write that so that the order is correct, we will have negative 4x plus 10. So you've got 2y equals negative 4x plus 10. We want y on its own, so we need to get rid of the coefficient 2, so we need to divide throughout by 2. So we're going to end up with y is equal to negative 2x, because negative 4x divided by 2 is negative 2x, plus 5. Now that we have our equation in gradient intercept form, we can simply read off the gradient and the y-intercept. So our gradient is going to be negative 2, and of course our y-intercept will be 5. For our third example, of course, it wouldn't be the topic of linear relationships if we didn't have to sketch a graph. So now we're going to be given an equation where we need to find the gradient and the y-intercept and sketch the graph. So you can see my equation here is x plus 2y is equal to 6. It's not already in gradient intercept form, so I need to put it in gradient intercept form. Remember, I want the y on its own, so I need to start taking steps to make that happen. So if we've got x plus 2y equals 6, I want to move that x over. So same as before, we're going to subtract the x, but instead of writing it as 6 minus x, I'm going to write it as negative x plus 6, just so it is in that correct form. So we're going to have 2y is equal to negative x plus 6. I'm going to divide throughout by 2 to get the y on its own. So that's going to give me y is equal to negative half, or negative 0.5x plus 3. So reading straight off my equation now, I can see the gradient is negative 0.5, or negative 1/2, and my y-intercept is 3. So that's where I'm going to start drawing my graph, is with my y-intercept. So I know that my line crosses the y-axis at 3, so I'm going to put my first point there. If my gradient is negative 1/2, what that means is I have a negative rise of 1. So I'm going to go down 1 unit, and across 2 units, because 1 being my rise, over my run being 2. And that gives me the point 2, 2, because I've gone down 1 and across 2. So that's my second point. I join those up, go through my Cartesian plane, and I have my graph of x plus 2y is equal to 6.